Hello students, today's agenda is to turn in homework. You will be learning about properties of parallel lines and you will be able to work on 7.5. Today students will be able to identify angles formed by two lines and a transversal and find angle measurements. And these two lines are parallel lines. So I'm going to start with some postulates and theorems. And first of all, a postulate is something that is taking us true without proof. Okay, so we can use that as a base as well. And you'll see in a minute. So it says corresponding angles, postulate. If a transversal intersects two parallel lines, then corresponding angles are congruent. And corresponding angles are those angles that I told them, look at this. They look exactly the same. It's like two little boots. You're not going to wear two boots that look different, right? So they look exactly the same, or we call this double L also, but they can also be on the other side. So this is another pair of corresponding angles. It's like if you cut it halfway, you grab that piece and you put it on top of the other, then the corresponding angles are angles that fall exactly on the same place. And those are congruent, meaning that they have the same measurement. Okay? Again, it's a postulate, so it's taking us true even though there's no proof. Alternate interior angles theorem. Theorem means that you have to do a set of proofs to show that it's true. So it says if a transversal intersects two parallel lines, then alternate interior angles are congruent. And so this is a set of alternate interior angles. Angle 3 and angle 1 are alternate interior angles. Alternate because they're on the opposite side of the transversal. Okay? And interior because they're inside of the two parallel lines. They're inside. And so angle 3 and angle 1 are alternate interior angles. So the corresponding form two exact angles. In here, it's like a Z. And I think of A through Z to remember the name. Alternate interior angles is the one that forms letter Z. Same side interior angles theorem. If a transversal intersects two parallel lines, so these are my two parallel lines, then same side interior angles are supplementary. So they're on the same side of the transversal. So angle 2 and 1 are on the same side of the transversal. And interior because they're inside of the parallel lines. Okay, so they are always going to add up to 180 degrees. So we need to remember this. I believe you saw this in the previous lesson, but we need this to be able to find angle measurements. Okay? And so let me show you a proof for alternate interior angles. You can actually do one for the same side interior angles as well, but we're going to do this proof. And so it says proof of alternate interior angles theorem. Given that line L is parallel to line M, now you're going to prove that angle 1 is congruent to angle 3. So this is alternate interior angles, angle 3 and angle 2 actually. These are the alternate interior angles. So you're going to prove that angle 2 is congruent to angle 3. Okay? Again, alternate, remember, alternate is from A to Z. So it's these two angles right here. It forms a weird Z. Okay, from the A to Z. Just to remember the name, the A is connected to the Z. The shape that it forms and the name. And so the first thing that we are going to state is that line L is parallel to line M. And the reason? That's given to us. Then we're going to say that angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2. And the reason, if you remember, this form the two, let me see, I'm gonna mark it with a different, I'm gonna do the purple. So angle 1 is right here, angle 2 is right here. If you remember, we said that corresponding angles, which is like the little boots, okay, they are exactly the same measurement, and it's a postulate, so we take it as true, and we can say corresponding angles, corresponding angles, postulate. Again, we don't need to prove that. All we have to do is just literally cut it, grab that, and put it on top of each other, and we notice that they are congruent. Okay, a postulate doesn't need to be proved. Okay, the next thing that we're gonna say is that angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. And the reason is because we learned this in the previous lessons. They are vertical angles. Okay? So if you notice, angle 2 is congruent to angle 1. And also, angle 3 is congruent to angle 1. So by the transitive property, which we learned in last lesson, you need to go and review that, we can say that because both of these are congruent to the same thing, then that means that they are congruent to each other. So by the transitive property, we can say that angle 2 is congruent to angle 3. And that's by the transitive property. So that's the theorem, that's the proof of alternate interior angles. That's how you prove a theorem. It's a set of proofs, and you have the statements and reasons. By the way, this is called the column explanation of the theorem, or a column proof. Okay? Okay, so now that we have that, let's apply it. It says, name a pair of, and then you have A, B, and C. Name a pair of alternate interior angles. Oh, from the A to the Z. So you can just look for any angles that are inside of a Z. So it's angle 3 and 6, angle 3 and angle 6. Why? Because they form this Z right here. Okay? But you have another setting here. You can have angle, the other Z, but backwards. So it's 4 and 5. 4 and 5. Okay? So we can say angle 4 and angle 5 is another set of alternate interior angles. Same side interior angles, and I didn't mention that in here, but this has the letter C. Okay? So it's like you embrace it, put it together to make 180. Together, the two angles, together, 180. Okay, so same side interior angles. Also, you have two sets in here. So you have letter C is 4 and 6, angle 4 and angle 6, because they're on the same side of the transversal, on the same side, and they're inside. Same side, interior, in the interior of the two parallel lines. And that's why they're called same side interior angles. Okay, but we also have another setting here, another letter C, but backwards. So 3 and 5, angle 3 and angle 5. And it's asking only for a pair, but I'm putting the two possible ones in here. Corresponding angles, postulate. So in here is the little boots. So you have 2 and 6. 2 and 6 is a set of corresponding angles. It's the one that falls exactly in the same position. On the left top, it's another set. So 5 and 1, angle 5 and angle 1. And sorry, I'm going to be going back and forth because I don't have enough room. We have bottom left, it's number 3, and bottom left. If you notice, again, they look the same. So angle 3 and 7, angle 3 and angle 7. Okay, right there. And then we also have angle 4 and angle 8. Okay, let me see if I can write in here. Whoops, it broke. Angle 4 and and angle 8. Okay, so if they ask you for a pair, you can just write one of them, but that's how you would find it. It's like little boots, but they're turned around, but they look exactly the same. Okay, exactly the same, 4 corresponding angles. Same side interior angles, letter C. Alternate interior angles from the A to the Z. De la A a la Z. Okay? Okay. Now, in here they give you a diagram, and let's see if I can fit all of this. But it says, name the 2 lines and transversal that form each pair of angles. And let me see. So angle 2 and angle 3. If you notice, angle 2, it's right here, and angle 3 is right here. So if I look at those, angle 2 and angle 3, they don't look like little boots on exactly the same, but if I connect it in here, they form letter Z. So they are the 2 lines that are parallel to each other. Basically look for something that will never touch, and it will be, oh, I don't have names in here. So I think I'm using the wrong diagram. Sorry about that. Similar things. Okay, so in here, let me see if I can zoom out a little bit. Okay, it says in the figure L is parallel to M and T is parallel to W. Find the measurement of each angle. I'm not sure what I'm doing here, or I didn't name the other one. Okay, I'm just gonna put names in here. So line L and M and P and Q. Okay, so the 2 lines that form these angles, 2 and 3, are line L. L is parallel to M, and the transversal will be the lonely one. So in this case, it will be line P with transversal P. Okay, for the next one is angle 6 and 11. 6, 11. So I have this right here. This is 6, this is 11. And so I connect this, so it's letter Z. So that means that they are, well, we'll go to that later, because it says what type of angles do they form, or they are. So this one is A through Z. That means I'm gonna do these answers. It's from A to Z, so alternate interior angles. So I'm answering question 2 already. And 6 and 7, the 2 parallel lines is these 2 lines. So it's line P and Q, because they will, if you extend that, they will never touch. So P is parallel to Q with transversal. And the transversal is the only one that forming that Z is alone. So it's M. final, oh, and I'm gonna go back to this one, L and M with transversal P, L and M with transversal P. What kind of angles are they? So I'm answering this question right here. Well, these are, letter C is the same side interior angles. And we're gonna go next to 5 and 6. 5 and 6. Let me use a different color. So 5 is right here. 6 is right here. If you notice, they look exactly the same position. And the two lines that are parallel, well, if you were to extend, this is the same line. So that wouldn't be the two parallel lines because it's the same line. But this is one line, this is another that they will never touch. Okay, so it's L and M. So L is parallel to M with transversal. And the transversal is line P. Okay. What kind of angles are they? Well, they form the little boots or double L. And I think of double L as, oh, if it has a double L, then in the name there is a double R, corresponding angles. Okay? Double L, or double boots, then double R. If V forms a letter Z, from the A to the Z, so it's alternate interior angles. It has the A for letter Z, A in the name. And C has the same sound as same side interior angles. Okay, maybe those tricks will help you, maybe not, I'm not sure, but you can try. And finally, it doesn't say to find the measurement of the angle. Sorry that I confused it with the other one, is because I didn't have the labels of the lines. But basically, if we have, from previous lessons, we learned that in here, these are adjacent supplementary angles. So they must add up to 180 degrees. So if this is 115, then this is 180 minus 115 is going to be 65 degrees. Also, vertical angles are congruent, so this is going to be 115 degrees. These are vertical angles, so it's going to be equals to 65 degrees. And so if you notice, many of these are connected because there are two sets of parallel lines, and so they are same measurements. These 2 and 4 are corresponding angles. Same, see, notice how they have the same measurement. So if this is 65, this is going to be 65. These letter C, okay, they add up to 180 degrees. Same side interior angles add up to 180 degrees. So 65 plus what equals 180? Well, it's 115. Vertical angles is 115, and this is going to be 65. So basically, we can just get all of this as corresponding and cut this in here. So 11 is 65, and down here is 115 degrees. This top is 115, and only because they are all sets of parallel lines, and this is corresponding to this is 65. Okay, these are letter C, they're 180, so this is going to be 115. Another C, or we can have alternate interior angles, which are congruent. 65, so 65. Okay, letter C, Z, zeta, they are congruent. Vertical angles, congruent, and then vertical angles, they are congruent. So this is pretty much using some of the knowledge that we have from previous lessons. And I'm gonna do something similar to this other one that I had shown you before. I'm so sorry. But it's the same idea, okay? Same idea. If this is 67, vertical angles are 67. It's like when you have an X and they're like skipping right in front, okay? Oh, 67, not 65. And then in here, you're gonna have, instead of 115, so it's 113. And so these are vertical angles, so it's 113. Corresponding angles. And so, buenas noches. 67. We're almost done here, so this is 113 because they are corresponding angles. Vertical angles is 113. These are same side interior angles, so they should add up to 180. Vertical angles, 67. And so basically, again, you just copy this exactly the way it is. 113, 67, 67. And those are called corresponding angles. Okay. And finally, 67 and 113. And here is 113 and 67. So that's it for today. You're now able to do 7.5 and have fun.